Hi, this is Wendy, and welcome to my No Frills Java video series. I don't do any fancy video production or anything, so you might hear traffic in the background, or my cat meowing, or my next door neighbors fighting in Hindi, but whatever. When you're coding in the real world, you're hearing lots of these noises and other noises, so you just suck it up and get used to it. I'm going to show you some Java stuff, and I don't have the time or inclination to create any fancy videos with animations and all that other useless stuff. We're just going to learn and code with Java. Now in this video series, I'm going to introduce you to the basics of regular expressions and how to use them in a Java program. In the first video, we learned the basics of regular expression syntax, and we wrote a few really basic expressions. So if you just found this video and haven't looked at the first one, you want to go back and do that first. In this second video, we're going to talk about using character classes and how we would use them to match ranges of characters and groups of characters in your expression. And in the third video, we'll see how we can use quantifiers to specify how many of a set of characters we want to match in a string. In the fourth video, we'll talk about escaping special characters and also about how you can use meta characters as shortcuts for common expressions. In the fifth video, we'll learn how to create way more advanced expressions by using capture groups. And finally, in the sixth and seventh videos, I'm going to show you how to use regular expressions in a Java program. If you're only here to learn about regular expressions and not learn about Java, then you can skip the last two videos. You can get what you need from the first 5 videos. That's totally fine. Now in the previous video, we learned the basic syntax of regular expressions, and we wrote a few basic patterns using a regex tester tool. But the patterns that we wrote were for exact literal matches, which aren't really very useful on their own. Now, what if you wanted to search for any letters, not just specific letters like foo or ex, for example? What if you wanted to make sure an input value contained only digits and nothing else? These are common tasks, so there are tokens that you can use called character classes. A character class defines a set of characters or a range of characters, and we can use square brackets to contain the set or the range of characters that we want to match for. So you'll notice that part of the syntax includes these square brackets. So for example, I'm over here in my regex tester. Again, if you haven't set one of these up or gotten access to one, you can find out how to access a free regex testing tool on the internet in the previous video. So let's say, for example, I use a character class that contains the letters E, F, and G. If you look through your dummy text, you'll notice that it's finding an individual match right here in the alphabet. It's finding an individual match. Notice that's one single match. It's character number 47 in my particular set of string values. And then there's the F, and then there's a G as a match. It's matching all the Fs in foo, all the foos that we did in the previous video as an exercise. These are all individual matches, and you'll see lots more down here. Any occurrence of a letter E, a letter G, or a letter F is considered a match. Again, we have that global flag turned on, so it's finding all of the matches in my giant, look at this thing, my giant input string. Wow, it's huge. But that's okay. So this is a single token. Remember in the previous video we talked about tokens. So this is one single token, and that token matches a single character if that character is one of these. If it's an E, an F, or a G. So that's how, again, that's how tokens work. If I take off the square brackets as an example, now it's different. Now I have 3 tokens, and so I have an E, an F, and a G. So what this is going to do is it's going to match, because I have 3 tokens, it's looking for a string that contains these exact tokens, in this case an EFG, all following each other. So you'll notice a difference in our matches here. This is one single match EFG. See how it says it's from character 47, 48, and 49, right? Your numbers, again, might be different, just depends on what else you have in your text area here. So this is a single match. It matches these 3 tokens. Remember when we did the first set of exercises back in the previous video, we were doing literal matches, and that's exactly what this is. It's literally matching an E followed by an F followed by a G. So this match here, all 3 letters are highlighted as a single match. Previously, they were highlighted as individual matches. Now they're one single match, one single selection. So that's the difference. When you use the character class, you're creating a single token that contains one of these things. So one of these letters, but without the brackets, it's 3 tokens that all have to match together. Again, to summarize the difference, using a character class with the brackets, it's a single token. It's matching any single letter that is an E, an F, or a G. Whereas without the brackets, that's 3 different tokens. So it's matching all 3 letters, E, F, G, appearing together, E, F, and G. So it won't match E's, like 3 E's or 3 F's or 3 G's. It has to be E, and then an F, and then a G. Now, another way that we commonly use character classes is by using an operator called the exclusive operator. The exclusive operator is this caret symbol, C-A-R-E-T, not C-A-R-R-O-T like the food. This is the character called caret. It's on your keyboard, usually on the same key as the number 6 on a standard keyboard. So this operator is the same as saying not one of these, or you might think of it as a not operator. If you've done programming before, it's the same thing. Now you place this symbol inside a character class. It's so important that you put it inside the square brackets. If you put it outside the square brackets, it's a completely different symbol, and we'll cover that in a later video. So make sure you put the caret inside the square brackets. So this means not one of these. So in this case, this will match any single character that is not an A, a B, or a C. This example here will match anything, any character at all that is not a 0. It looks like an O, but it's a 0. I know because I typed it, but otherwise you wouldn't. That's why it's so important to use a good font that actually differentiates zeros and O's. Anyways, that's a not 0. And then here's a cool example that'll crop up later. This says it's any character that's not one of these individual symbols. So we can use the not operator. So if we try it, here, if I put my character class back on, because we had taken it off earlier, and I stick the exclusive or the not operator inside, what you'll notice is it's looking for, and again, this is a single token, so it's looking for any single character that is not an E, not an F, or not a G. So it's highlighting, it's even highlighting spaces, because spaces, white space, it's not an E, F, or a G. So it matches. So it's like all this stuff, everything, even these symbols, because they're not an E, an F, or a G. And you'll see it's skipping the E's, the F's, and we've got some G's here. It's skipping the G's as well. So it's matching anything at all. Again, even the spaces, any single thing that's not an E, F, or a G. You might be thinking like, why would I use that? Oh, trust me, there's going to be lots of instances where you could use this operator. So that's the not operator. Now, as I said before, be careful. You don't want to put the caret outside of those square brackets because that's a totally different thing. And like I said, we're going to cover that in a later video. Again, I think it's the 4th or 5th video, but don't worry about it right now. Now, you can also use ranges of values inside your character classes with or without the not operator. So for example, if I wanted to search for digits, I can do 0 to 9. So that will look for any single digit. So you'll notice again, all of these digits are individual matches. You can highlight each one. You can tell by looking at the range there in the little tooltip window. These are all individual single character matches because I only put one token. It's any digit from 0 to 9. So it's not highlighting anything that is not a digit. If I wanted to highlight anything that was not a digit, then there you go. I can just reverse it. So I can put the not symbol in there and it's highlighting or matching any of the characters, including symbols and spaces and all that other stuff, letters, brackets, anything that is not a digit, it is highlighting. Now you can do this if you don't want 0 to 9. You could say, for example, from 2 to 7. And it'll only match 2, 3, 4, 5, 6, and 7. So see how it's not matching. Here we go. So it's not matching anything that's between 2, 4, 6, and 7. So that's with the not. I can take it off. And it'll only match 2, 3, 4, 5, 6, and 7 digits. And you can do this all with letters as well. If you want to match, any lowercase letter, just put A to Z like that. And it'll match any individual lowercase letter. Or if you want uppercase letters, uppercase A to Z, and it'll match any uppercase individual uppercase letter. And you can even do like we did with the 2 to 7. You could say only the first 10 uppercase letters. What is that? A to J, I think. So you could say only the A to J letters, and you'll notice it's ignoring all the rest. You could say, for example, anything that is not an uppercase letter. You could do that. So caret symbol A to Z is anything that is not an uppercase letter. Notice again, when I say not an uppercase letter, it's selecting anything that is not an uppercase letter, including spaces, symbols, etc. You can do all of these things. Now, you can also, if you want to say, remember I was saying earlier, if you want to select all letters regardless of uppercase, lowercase, you know how to do this. You could say A to Z, and you can put your A and your Z in upper or lowercase. And you can select the case-insensitive flag. That would totally work. It's selecting any letter, whether it's upper or lowercase, but sometimes you don't have access to these flags, or it's just really inconvenient. Sometimes in some languages like Java, it's kind of inconvenient to access the upper and lowercase flag. So what we can do, I'm going to turn that off. You can do something like this. If you want to say any letter that's upper or lowercase, you just put A to Z, lower, A to Z, upper. So that's still a single token, but it has two ranges, A to Z, A to Z. Notice it gives you the exact same thing as either the lower or upper A to Z with the I flag, the case-insensitive flag. So this will match any single upper or lowercase letter. So that, again, in Java, that comes in handy because in Java, you can access the case-insensitive flag, but it's just a lot more typing. And then you have to remember the name of the constant. It's like, forget it. I'll just type it this way. Now, as I mentioned earlier, each token in the pattern matches a single character. So that pattern we used earlier, EFG with no square brackets, that has 3 tokens. So it's going to look for those 3 characters. Whereas EFG with the square brackets is a character class. That's 1 token. It's looking for a single occurrence of E, F, or G. Now, obviously, in most situations, you're going to want to look for more than one single character. And so you could do, this is kind of cheesy, but you could do something like this. So this has 2 tokens. It looks for an uppercase A to Z followed by another uppercase A to Z. In other words, it's looking for 2 uppercase letters side by side. So there's 2 tokens. The first token matches a single uppercase letter, and the second token matches a single uppercase letter. Therefore, this expression will match a pair of uppercase letters that appear with nothing in between them. Now, when you learn about quantifiers, and I think that might be in the next video, you'll learn a better way to do this, but for now, like I said, I just want to start off easy and work our way into it gradually because a lot of people, they find regex kind of scary, so we're going to do this nice and slow. So if we wanted to try that out, for example, I'll just do the same example, A to Z followed by another token, A to Z, like that. There we go. So you'll see that it's matching individual pairs of uppercase letters. There you go. See? Notice that it's not matching these ones at the end because they're singles, right? The space counts. So it's not matching J space, or it's not, sorry, that's an F. My eyesight's really bad. So it's matching an F, or it's not matching an F followed by a space because, right, it's not 2 uppercase letters. So that's why we're getting only these individual pairs of uppercase letters. That means, too, you could have a character class that matches letters and digits. So, for example, I could look for any upper or lowercase letter followed by any digit. I could do something like that. I don't think there's too many of those here. Oh, there's one, an E, that's exponential notation, an E followed by the number 4. So it's only matching a single letter followed by a single digit. So that was E4 was the one that we just saw. If I do foo 49, notice it's matching the O and the 4 because it's a letter followed by a single digit. So if you typed in, for example, June 25, it's matching the E that's followed by the 2. It's matching any upper or lowercase letter. I'll try one in uppercase. Any upper or lowercase letter followed by a single digit. Another example that we saw on the slides was with symbols. So we had something like this. So this is a token that will match any one of these individual symbols. So there we go. If you're trying this on your own and you're typing in the symbols, just be careful. Some symbols need to be escaped, and I'm going to cover that in a later video. You'll notice I purposely left out a couple of symbols. I chose these symbols because they don't need to be escaped. Again, starting off nice and easy. So there we go. Okay, so let's try and practice a few things to see what you've learned. So create the regular expression that matches an uppercase letter followed by a lowercase letter. And when you've got that working, try an expression that matches any digit followed by any upper or lowercase letter, followed by a digit, followed by any lowercase letter. Ooh, nice. And then test your expressions out. And if you need to add some sample strings, that's totally fine. Go ahead and try these exercises, pause the video, give them a try, jot down your answers somewhere, and then when you're done, come back, resume the video, and I'll take them up with you. Okay, so hopefully you had a chance to try these out. My first question was to look for or find a match for any uppercase letter. So we know that's going to be our uppercase A to Z, followed by any lowercase letter. So we're going to use the same character class, but this time, whoops, with lowercase A to Z. So any uppercase letter, followed by any lowercase letter. So you'll see all of these matches are an uppercase letter, followed by a lowercase letter. There we go. The second one was a digit, followed by any upper lowercase letter, followed by a digit, followed by only a lowercase letter. So again, digit 0 to 9, followed by any upper or lowercase letter. So A to Z, whoops, A to Z, get that guy out of the way, like that, followed by another digit. And you can see it's already starting to find matches as we go here, followed by a lowercase letter. So I'm going to use the character class A to Z lowercase like that. So it doesn't find a match in here because these are all pairs of letters and digits. It's digit, letter, digit, letter. So here's one that matches. So digit, letter, digit, lowercase letter. Nothing in here because there's an uppercase and an uppercase. This one, digit, letter, it can be upper or lower, followed by digit and then lowercase. Whoops, there. And then lowercase letter. This one doesn't match because when it found the digit, the next letter was fine, but then the 2 was followed by a capital C, and this has to be a lowercase letter. So the fourth thing has to be lowercase. So that's why it didn't match. So there we go. So now these still aren't 100% practical. Like I said, we're kind of going slow, we're taking it easy, and we're learning it bit by bit so that we don't get scared of regular expressions like a lot of people are. But now that we know how to start creating some very basic regular expression patterns, that's fine, but these patterns are going to get tedious if we have to perform some standard tasks like matching a valid phone number. If you want to see what I mean, give it a try before you watch the next video. See if you can make a regular expression that matches a standard phone number in whatever country that you're in. So I'm in North America, so it might be something like digit, 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 and then a space, and then 3 more digits, and then a dash, and then 4 more digits. But whatever works, whatever country you're in, try and come up with a regular expression that matches a phone number, because this is something we're going to talk about in the next video where we learn about quantifiers and we can make those kinds of expressions a bit easier. But until then, thanks for watching.